Let's go to the third sum. 5 identical charges Q are placed distant on the semicircle as shown. Another point charge Q is kept at the center of the circle of radius R. Calculate the electrostatic force experienced by the charge Q. See in this sum, see there are 5 charges here. Okay, these are 5 charges. They are identical. It means they are same, and they kept equidistance. That means same distance on a semicircle. Okay, at center we have another charge that is small q. Okay, what is the electrostatic force on this small charge that you must find? Okay, let's see how to do it. First, let's name this charges as q1, q2, q3, q4, and q5. Okay, so all of them are same only, and for our understanding we write it as same. Now we must see what are the forces that are given. Okay, so let's see q1 and q5. Okay, let's take positive charges. So the force will be like this way. Okay, the force will be, say in this case, F1, and this will be F5. They are opposite each other, so they will cancel. Okay, so you can write here first one. Okay, so Q1 and Q5 produce forces F1 and F5. Okay, they are opposite and they cancel each other. They are opposite and cancel each other. Okay, so that is the first part. Okay, now let us see. So now Q1 and Q5 are not needed now. Okay, we need not taking calculation. Let's take Q2, Q3, and Q4. If you see Q3, it gives a force like this way, in this direction. Okay. This force will be, say, F3. Okay, so second one is Q3 produces a force F3. Okay, that we can see. Now let us take charges Q2 and Q4. Okay, this charge Q2 will give a force like this way. Okay. This force we named as F2. Okay. Now see, any force can be resolved into two components. Okay, we study resolution vector, force vector quantity now. So this force F2 is resolved into two components. This is actually force vector here. So we have two components here. This will be the vertical component, and this will be the horizontal component. Okay, so vertical component we learned, that is, like another color. The vertical component is F2 sine theta, and the horizontal component will be F2 cos theta. Okay, just based on pictures only. And then Q4 will produce a force here. Okay, it produces a force F4. Okay. Again resolved into components. Okay, like this way here. So this part will have F4 sine theta, and this will be F4 cos theta. Okay, you see that F2 sine theta and F4 cos sine theta will cancel each other. Okay, these two are opposite each other, so they cancel. But F2 cos theta and F4 cos theta will add. Okay, let me write that also down. Third part. Okay, so we see Q2 and Q4. Okay, produce forces here. Produce force F2 and F4. Okay, they have horizontal components. Okay, in that thing, if you see F4 cos theta, F4 sin theta, F4 sin theta and F2 sin theta cancel each other. Okay, cancel each other. They are opposite. This comes down, this goes up. Okay, but you see F2 cos theta and F4 cos theta will add. Okay, but F2 cos theta and F4 cos theta add. They are in the same direction. Okay, let's see total force now. What will be the total force? Okay, total force means you must add F3, F2 cos theta and F4 cos theta. So F is equal to F3 plus F2 cos theta plus F4 cos theta. Okay, so let's see what we get here. Now I erase this part so that I get a thing here. This bit. So from here to here I'll drop it out and write this thing. It's very simple only. Okay. I'll write this thing step here one time. So f is equal to f3 plus f2 cos theta plus f4 cos theta. Okay. Now f3 force, it's a electrostatic force. We learn the formula. That's 1 by 4 pi epsilon. I'll write as k into small q into capital Q. Why? Because it's small q and all the charges are capital Q, divided by distance is capital R square, plus f2 also we write it as this k into q into, okay, capital Q by R square into cos theta. Now see the angle here. See, this is 90 degrees. No, or this side we take half of 90 degrees is 45 degrees. So angle is 45 degrees. Okay. So cos 45, okay, plus f4 again, that is k into q into capital Q by R square. Okay, using Coulomb's law. Then again cos 45. Okay. Now you see what's common here, k into q into capital Q, that's common. So take it out. K into q into capital Q by R square. Okay. Into, if you take first term, that will give 1 plus the second term we had cos 45. Cos 45 value is 1 by root 2 plus again, see that cos 45 remains, that is 1 by root 2. Okay, let's add this and see. So k into small q into capital Q by R square into 1 plus, okay, this is 1 by root 2 plus 1 by root 2. Common denominator means you can add. Okay, so common denominator is root 2. Top will get 2. Okay, 1 plus 2 by root 2. Okay, now I'll erase it again. Let me write the next step here. Okay, let us also. So we take k into small q into capital Q by R square into 1 plus 2, we can write as root 2 into root 2 by root 2. Okay, this is down. So here root 2 and root 2 will cancel. Okay, so we get here k into small q into capital Q by R square into 1 plus root 2. Okay, this term we get. But now k value is, we know 1 by 4 pi epsilon. So let's write that down. 1 by 4 pi epsilon naught to small q into capital Q by R square into, this R square right clearly, 1 plus root 2. Okay, this is the force here. But if you notice that it's on the x direction. Okay, on the x direction means we can write I cap now. It's unit vector which shows direction. Because force is a vector quantity, okay, into I cap, and the force measured in newtons. The SI unit is newtons. So this is the answer that we need. Okay. It's a very simple sum only. Okay, go through steps and then you can write down one by each step by step. Okay, thank you for watching.